Hello, in this video let's discuss third question of today's contest. You are given two integer arrays nums1 of length n and nums2 of length n plus 1. You want to transform nums1 into nums2 using minimum number of operations. You may perform the following operations any number of times, each time choosing an index I. Increase that value or decrease by 1, increase by 1 or append the value to the end of the array. Return the minimum number of operations required to transform nums1 into nums2. Constraints are n is up to 1 if I and then both the values are also up to 1 if I. For example, let's take the first example. If the values are 136 and 2453, by doing some kind of operations by appending and incrementing and decrementing, we have to find the least number of operations to make nums1 equal to nums2. So firstly, what are the type of operations that we can do? Simply incrementing value by 1 in one operation, decrementing by 1 in one operation, and appending any element in one operation. Appending any element from the given v1 to end of v1 for one operation. And exactly one append operation should be done because the v1 size is n and the v2 size is n plus 1. So we can do only at most one append operation. So by appending any v1 of element v1 of I, we have to find the least cost to make both v1 and v2 equal. So let's take simplest example, right? So what is simplest example? So the first value, the size is 1 and the size of v2 is 2. So this is the least example that we can take off because the least size is 1. So if we take this example, what are the minimum number of operations to make v1 equal to v2? Let's check that, right? So we have 3. So let's assume that we are appending 3 first because we have to append 1 because we have to make length, we have to make one more length. So we have to append one element. So let's assume we are appending 3 itself because initially we only have 3. So after appending 3, we have to make both equal. So what is the cost to make this both equal after appending 3? It will be simply the difference of this. So we can do one operation by addition. So this will be 1. And for this index, the difference is 2. So we have to do 2 operations for this index. So simply to make index 2 equal is 2. So by one operation, we can make 3 equal to 4. And by 2 operations, we can make 3 equal to 5. So what is the total cost to make both equal? The first one is append because we appended 3 and then increase 3 to 4, that is the first operation, and increment 3 by 5 to 2 times. So 3 to 4 and 4 to 5. So there are 2 operations. So double increase. So the total number of operations to make here is 4. But is that the correct answer? Let's take other example also, other way. For example, what if we try to increase the initial value and then append the value? So initially here what we have done, we simply appended 3 first and then we found the operations to make both equal. But now what if we try to increment the value itself in the first go? So we made 4, 4, 5. So we incremented 3 to 4 and then we appended 4. Then what is the cost? Then 1 for incrementing the value first and then 1 for appending because we appended after increasing the value. So this is 1 is for increasing 3 to 4 and this one is for appending the 4 after incrementing. And then these both are still unequal, so we have to do one more operation to get these both equal. So now the only operations are required 3, but before it is 4. So what is the difference? The difference is in the before we initially appended the same element and then we found the total sum to make this both. But here we appended after increasing the value. So that's why the operation 1 is reduced. So now we got that by changing the value appending, we got the different value, right? So what if we try to make this 2 and then append 2 5 and then append? Let's check all the cases and check which is the minimum. So initially it is 3 4 5. So if we try to reduce the value and then append it, it will be very bad because by decreasing the value we have to make more operations to make those 4 and 5. So if we try to make 2 and then append 2, total operations will be 1 for decreasing and then 1 for appending and then 2 to make first index both equal and 3 for making 2 and 5 equal. So total number of operations are 7. And if we make no operation, if we try to make directly appending, the cost will be 1 1 1 1 1 2. So 1 1 2 because 1 for appending, 1 for incrementing, 2 for this incrementing. And then if we increase the value and then append, it will be 3 as we discussed. 1 for appending, 1 to increase for this and then 1 to increase originally and 1 to append and 1 to increase this. And now what if we try to increase to 5 and then append? So 2 for incrementing the value, 1 for appending and 1 for decreasing this. So total number of operations in this is also 4. So from this what we got, so the graph is simply like parabola, because it is highest initially. As we are reducing the number of operations, initially the value is decreasing, and then we got the minimum value, and then we are rising again. So from this we can clearly observe that this will be minimum at median. So what is median? Median is simply the minimum value. For example, like not the minimum value, the middle value. For example, if I have 443, 443. So what we are comparing, we are, for example, there is only one index, right? So what we are comparing, we are comparing all the three elements we have. So given 3, 4, 5, there are many choices to append. We can decrease and append, we can samely append, we can increase and append, and many things. So we are checking what is the minimum cost. So what we have done, we tried all the possibilities, and then from the graph we got that we are getting for the median value, because for 2, 3, 4, 5, how is the graph looking like? The graph is looking like this. So the minimum is at 4. So what is 4? 4 is simply the middle value of this 4. Middle of this is 3. So from this what we got? So what we got is, if we have only one sized array, then what is the minimum operations? So simply we can find the median, and then after equating the present value to median, maybe that is increasing or decreasing, and then making to median, and then we'll append, and then we'll do extra operations. So hope you got this. Let's check other example. For example, if this is 2, this is 1, this is 6. So if we have this, the median is 2, it means that it is better to append now only. No need to do any decrement or increment operation. Right? So what is the operations now? It will be 6. 4 for this, 1 for this, 1 for appending. And what if we try to increase this and append? Let's check that also. So if we try to increase and append, so that will be 3, 3 and 1, 6. And what will be operations now? So 1 for incrementing, 2 for this incrementing, 3 for this incrementing. So from this what we got? We got that there may be many different values where the answer will be minimum. But at median we can get the answer for sure. So the graph can be like this also, right? At these all values the answer is same, but median will be obviously in this line. So from this we got, if we have 3 values, the best is median. So after finding median, then we can append it, and then we can find the answer. So for length 1, it is this itself complex. What about length n? It is very simple. The only thing is how to find like which element to append, because here there is only one element, so we thought about when to append, but in this case there are many choices to append also. Then what we have to check, that is the only thing that is slightly difficult. So let's forget the condition about adding. So without adding, let's assume that there is no this value, like there is no appending. And now what is the minimum cost to get both equal? That is very simply the sum of absolute value of all the indices. So one operation for this to decrement this, other operation here, no operation here, two operations here, two operations here, and one operation here. And then simply we can find sum of absolute values of all these values to get the minimum cost without appending anything. So we got that is the minimum answer possible, because without these how can we make equal? So let's assume that we made these equal. Let's assume that we gave these operations to get these both equal. But what about appending? We will append which element? That is the next question. So now what we can do? We can try all the possibilities. So starting from 0th index, so let's assume that we are at 2, 1, right? So we are at 2, 1. And what is the last value? It is there, that is 4. So this is the last value. So now this is exactly like before 1. Like this is exactly like the case where the size is 1, because at every index we will try to make which one to add. We will start from 0th index. So we are at 0th index. So this is 2, this is 1, and this is 4. So now we will find minimum number of operations to make this. We discussed already what to do. We will find the median, and then we will append it, and then we will get the answer, right? So for this example, if we try to append this element, this index 2, maybe after decreasing, or maybe at the same, or maybe increasing, what will be answer? It will be 4. Why it is 4? Because 1 for appending, 1 to make this both equal, and 2 to make this both equal. So total cost is 4. But what is this cost? This is the cost for increment, like this is the cost for making all these equal. But did we remember? Because we already got that answer. We already got the answer to make these both equal, right? So now what we have to add? we have to simply take absolute value. We have to do the extra operations, because what is this for? This 4 indicates that the total number of operations to make all these equal. We have 2, 1, 4. So we are appending this, and then we are finding the answer. So what is 4? 4 is for answer by making all these operations. In this, we are making again other operations to make these both equal, but these are already included in the answer. So simply find the what are the extra number of operations that we are doing by appending this element. So if we get that, then we can get what are the extra operations, because the total number of operations to make these both indices equal is 4. And what is the operation to make these equal? It is 1. So we have to make 3 extra operations to get both equal if we append 2. So in this way, if we try to find the minimum number of operations, like if we try to find the operations for every index, if we try to find the extra operations for every index, then we can try to get the minimum value. So what is that minimum? That minimum is simply the number of extra minimum operations that we have to do. So we have these. So now what will be answer? It is simply the original cost plus 1 for appending, and then plus extra minimum value that we get. So hope you got this. So let's say we have n and n plus 1. So we'll start traversing from this. So we'll think what is the minimum cost to append this? Maybe increasing, maybe decreasing, or same, which we discussed before. So what is the cost to get that, and what is the extra operations to get that? Because the difference of these is already included in the answer. So we are caring about only the minimum number of extra operations that we want to make. So we will get minimum for this, and then we will get what are the minimum operations if we add this also, and we will get the minimum extra operations, and for this, and for this, and so on. And finally, what is the total number of operations? So that is simply the total absolute sum of difference plus 1 for appending, and plus 1 for plus extra, which is the least to extra operations that we are going to do for adding the element. Let's check the code. So simply, what is the minimum operation sum? It will be simply absolute sum of all. So sum of abs of difference, and then what is the least extra difference? It is simply long of max, and then what is the appended element? It is simply v2 of n, because that is the last element, right? So that is the last value, and then traverse all the operations, all the indices. So firstly, this is the first value, this is second value, and this is the last value. So this is simply what is it? It is like A, B, and C. This is what we discussed, right? So we are appending some value A. This may be increasing or decreasing or same. We already discussed in the beginning. So after optimally, we have to make all these equal. And what is that cost? It is median. And what is median? So median is simply not the minimum, not the maximum, the middle one. So how can you find that? We can simply find the minimum of all three, maximum of all three, and what if we try to sum all those and add the difference, subtract the difference of these both, so that we will get the middle one, right? So what I am saying is, let's say we have 3, 4, 5. So how to get the middle value? So there are only 3 elements. So one is minimum, one is maximum, the other is the required median. So how can we find that? Simply we can find the minimum value, which is 3. Simply we can find the maximum value, which is 5, and then we can find the sum of all these, which is 12. So we got all these. So 12 minus 3 minus 5 is equal to the median value, which is 4. So simply we can find minimum, we can find maximum, we can find sum, and then we can find the difference. So simply find the minimum, find the maximum, and then get the median value, which is the sum minus minimum and maximum, and then find the extra, like find the total operations. What are the total number of operations to make this equal? We got this, right? Because we have ABC, we are going to make this equal. And what is the cost? Let's say we have 3, 4, 5. We are making all these as median. Then what is the cost? It is simply this minus this plus this minus this. Median minus minimum plus median minus maximum, or minimum minus median minus A, median minus B, median minus C. Anything is fine. So all sum of these, and then what is the extra cost? Extra cost is simply the above cost minus absolute sum, because we already added here, so we are subtracting here, and then after subtracting, take the minimum cost, and then simply final return sum plus list plus 1. This one is for appending, this sum is for indices equalizing, and list is for capping, like adding the element and then finding the minimum value. So if you have any doubts, comment below. See you in the next video.